So today we have equations. We have some exponential equations at the beginning, and we did some of those in section 5.1. So we're going back to it again, and then we will have equations that have logarithms in them. So I thought I would do just one of the exponentials to review, one of the easier ones. So problem number 3. And remember with these, what you try to do is write them with the same base, if you can. Now, if you play in your calculator, even 81 squared is really big, so 81 is not going to work. You might remember that 81 is made out of 3s. And so 3 to the 4th gives us 81. And so you want to check on your calculator, does 3 to some power give you 243? Because you need the same base. So if I try 3 to the 5th, that will give me 243. So that is going to work. So the 81 I will do as 3 to the 4th. And 243 as 3 to the 5th. And then these will multiply. So we have 3 to the 4x equals 3 to the 5th. And then you can set the exponents equal and solve. So we have 4x equals 5. Divide by 4, x equals 5/4. And there we go. So that was how the exponential ones work. We'll go down to problem 5. And this one just had a little bit of tricky work on it. It's still an exponential equation. So we have 2 to the 4 plus y times 2 to the 3rd equals 1 over 1024 to the y. So our candidate is going to be a base of 2. Remember your rule: when you have like bases multiplied, you keep the base and add the exponents. So we can combine on this side and have 2. The exponents are going to add, so that will give us 7 plus y. Excuse me 1 second. Sorry. All right, so you want to play with your calculator and see 2 to what power will give us 1024. And so let's just try 2 to the 8th. It needs to be pretty big. Well, not big enough. So let's try 2 to the 10th. And that's the right choice. So also it is in the denominator, so remember that's a negative exponent. So I have 2 to the negative 10y. Then you have your setup. So it took a little work to get there. Now you set your exponents equal. So we have 7 plus y equals negative 10y. And we'll subtract this y from both sides. So we have 7 equals negative 11y. And we need to divide by negative 11. So y equals negative 7 over 11. Whoops, not 10, 11. Good. All right, we'll move on to problem 9. And this one is still an exponential equation. It just looks so big. I thought we would look at it. Right, so since it's an exponential equation, we want to try to write these as the same base. And I remember something about 7 to a power giving me 343. So I'm going to check that. So let's try 7 to the third. All right, so 7 it is. So I have to try 7 to some power and see if I can get 2401. So let's try 7 to the fifth. Whoa, too big. So it must be 7 to the fourth if it's going to work. All right, so here I have 7 to the fourth. And then that is x minus 4. And here I have 7 to the third. And that is x plus 3. And remember that these are going to multiply. You will need parentheses. The 4 will go times the whole thing. Same thing here. So we can go ahead and take them down in the same step, but they are going to multiply. So then it's just solve. So 4x minus 16 equals 3x plus 9. Subtract your 3x from both sides, gives us x minus 16 equals 9. Add your 16 will give us x equals 25. Good. All right, problem 10 is our first one with an exponent where we can't do this. So we will have to have a new method. So we have 3 to the t equals 45. So your 3 is a prime. So this is as low as this one will go. You can test, but there is not a way to write 3 to a power and get 45. So you need another method. And if you remember back to your logarithm properties that we did for 5.3, we had one that if we're taking the log of m and it's to a power, then the power will come down. And so that's what we're going to use. We're going to take a logarithm of both sides, and you do this when you are trying to solve for a variable that's in the exponent position. So t is an exponent. We want to solve for it. We couldn't do the bases the same. So we're going to take a logarithm of both sides. Usually they will use a common log unless this is a base 10. I'm sorry, usually they will use a natural log unless this is base 10, and then they would do common log. Both would work, but just that's what's done more often. So I'm going to take a logarithm of both sides. So I'll do a natural log of 3 to the t is natural log of 45. So whatever you do to one side, you have to do to both sides, right? That forces, with this logarithm property, the t to come down, which is what you want. And now you're just going to isolate t. This natural log of 3 is just some number. So we can divide by it on both sides. Now, don't try to do any math between the 45 and the 3. You're not allowed, and I really should have the parentheses on there. This is the exact answer. Right, and then they want us to approximate it. with a calculator. So we'll get our calculator. And we're going to use the natural log button. Put this down just a tiny bit so it's in the record part. Natural log of 45, close, divided by natural log of 3, close, enter, and we get, so now we're approximate, 3.4649 because I believe this asks for 4 digits. So they want 4 decimal places. I need to see 5. The 7 is going to push us up, which will push this one up. So 3.465. And I think you need to put the 0 at the end. The answer key did not. So we will type it in and see what it says about my answer. And it's going to mark me wrong for the first part. All right, so that was fine. But it did take it without that 0. So, all right, next I picked 11. This one you need to use log on, common log, because it is base 10. So we have 10 to the x equals 1.59. There is no way to write 1.59 as 10 to a power, so we need to take a logarithm to force the exponent to come down. So we'll take a common log of both sides. That will force your x to come down. So you have x times log base 10, and this is really, log of 10. Log base 10 of 10, this piece equals 1. And so we just have x times 1 or x here. And log 1.59. This one is actually solved. This is the exact answer. And then you will put it in your calculator. You need to use the common log button this time. 1.59. And there we go. And now we are approximate. So 0.2039. 9 is going to push us up. So 0.2014. Right. I did pick 12. It has one extra piece on it that you need to deal with first. So we have negative 14 e to the u equals negative 6. And you can switch and use whichever log you want, natural log or common log most of the time. If there is an e, you have to use natural log. If there is the 10 there for the base, you have to use common log. Otherwise, you can use whichever you want. But normally you will see them use natural log. Right, before we're allowed to do that, we have to isolate this piece that's to the power, which means we need to get rid of this negative 14. So we're going to need to divide by that on both sides. And the 2 negatives will give us plus. Also, this will reduce a common factor of 2. 2 will go into 6 3 times, and 2 into 14 will go 7. And you can use your calculator if you have a hard time there. All right, now I'm going to take the natural log of both sides. And that forces the u to come down. So u times the ln of e ln of 3/7, and the ln of e is 1, so you don't need it. So you have u equals the natural log of 3/7. That is an exact answer. And then you will go in your calculator to get an approximation. So natural log of 3 divided by 7, close, enter. Right, and so here we have one that is negative. The 9 is again going to push us up. Good. All right, now we're going to switch and look at equations that have a log on them. These were still exponential equations. We took a logarithm of both sides. With equations that have a log on them, there are two kinds. One will have a log only on one side, one log on one side. And for those, which we're going to do first, you will just switch the form like we did in our first section, 5.1. If you have one log on both sides, then we will use another method. All right, so we have log base 10. Yes. So we have log base 10 of negative 7v plus 1 equals 2. So this kind you're just going to change the form to be able to solve it. Remember, you do a spiral around the equals starting at your base. So we will get 10 squared equals negative 7v plus 1. Now you have a plain equation. 10 squared is 100. Right, and we'll isolate the v. So subtract your 1. Give us 99 equals negative 7v. And we'll divide by negative 7. So v equals negative 99 over 7. Now, with the logarithm equations, you have to check every answer to make sure that your domain is okay. And remember, for the domain of a logarithm, the piece you're taking the log of has to be greater than 0. So you don't have to check through the whole thing. You just have to check that your domain is okay. So I'm going to plug this answer in. So I have to check. Because I worry a little if I see the negative, but it had a negative there. So the two negatives are going to multiply and make a positive, so I don't really care. It actually works out to 99. All right? So 99 plus 1, that's good. That's positive. We're good. So it does check. And so the answer is negative 9 over 7. Right, 14. So we have negative 6 plus 19. Natural log of v equals negative 17. All right, first job is you have to isolate the logarithm. So you're going to take off anything added or subtracted. So you're going to add a 6. So that gives us 19 ln of v equals negative 11. Then you need to divide by 19. So we have the ln of v equals negative 11 over 19. All right, and now you will change forms. Remember that your base here is e, so you might want to write it on just to help you. You're going to go in your spiral. So we have e to the negative 11 over 19 equals v. That would be the exact answer. I want to try to put that one in because the answer it gave me, it made me shift it and have a positive exponent. So it was 1 over. But I want to try to put it in this way and see if it marks us wrong. And a fraction up here. All right, and it'll mark the other one wrong, but we'll see if it takes it. So it will take that, or you can shift it and make it a positive exponent. So either answer would be acceptable there. To go in our calculator for the approximation. So we'll just do second e. All right, we're going to raise it to a power. And I'm going to put this in a parentheses to keep my whole fraction together. So I have a negative 11 divided by 19, close parentheses. You're doing some math there on the exponent position. So parentheses are your friend. So we get 0.5608, and the 8 will push us up to 0.5605. I'm just going to skip because it is such an easy one. 10 squared equals t. All right. I'm actually going to skip all the way from here down to 17 I put down to do. It just has one solve step, so it's still not a big deal. So the log base 5 of t plus 6 equals 3. So change your form. 5 to the third equals t plus 6. And 5 to the third you can work out is 125. And subtract your 6 from both sides. So this gives us 119 equals t. Remember, you're supposed to check these, but 119 plus something, it's going to be positive. That's all you care about. All right, so this should work. And there we go. All right, now we'll go to 19. And this one, it actually is still just going to have a log on one side, but we have to condense first, and then we will still work it the same way. So log base 3 of x plus the log base 3 of negative 8x plus 18 equals 2. So remember on your properties from last time, the log of a product is equal to the sum of the logs. So we have a sum of the logs. So to condense this, we have to write it back as a product. So writing log one time of x times negative 8x plus 18. And then you're going to change the form. So you had to condense first so that you only have one log. And you're going to go this way and back this way with our spiral. So we have 3 squared equals negative 8x squared plus 18x. 3 squared gives us 9, and Good there. Sorry. Right, we'll subtract the 9 to the other side to get a 0. And I factored out the -1. I don't like a negative on, so we have a quadratic to solve. So I factored out the -1, and that looks like all I can do. So -1, we're going to take it out. It's going to change all your signs. Now, you can divide by -1. It's still going to give you 0 here. So it is not going to matter. So we're dividing out the -1. And it's gone. And now I'm going to have to try to factor on the other side. All of these I worked on factored. So I am just going to go to the answer rather than spending a lot of time on the factoring. And I made, let's see. I have an arithmetic error up here. When I moved this 9 to the other side, it should have been minus. So it would not have factored at all, which will make this one plus. All right, because I factored the -1 out. Sorry about that. So fix that. And that tells me I need like signs if I have a plus here. And they're both minus. And so 4x and 2x were my choices. And I tried 3 and 3 and it worked. So by working, you check outside and inside. So minus 12x and minus 6x gives you minus 18. So it did factor, so you set each one equal to 0. So this one is 2-step. You're going to add your 3 and divide by 4. So x equals 3/4. This one, same thing. It's a 2-step. Add your 3 and divide by 2. So 3/4 and 3/2. Remember, you have to check. So we have to go back up to the original equation, not just here, all the way back. So the 3/4 is fine here. 3/4 over here. So -8 times 3/4. It should be okay. So -8 times 3/4 is 0.75. It gives me -6 plus 8, so that's okay. And the other one was 3/2. And so 3/2 here would be okay. That's bigger than 0. 3/2 here. So -8 times 3/2 is 1.5. Is a -12. -12 plus 18 still gives you positive. So we're okay, and that means that they both work. So we have two answers, 3/4 and 3/2. And we did check. Because on lots of these problems, you'll get an answer thrown out. So just a heads up there. When you start getting no solution or one of them thrown away when you have two, don't be surprised. That is very common. All right, that was 19. And 20 I picked. This one also you're going to have to condense. So log base 3 of x plus 15 plus log base 3 of x plus 9 equals 3. So this is adding. They can combine. And it would be log base 3 of this product. Right, and then we can change forms. So we have 3 to the third equals this product, which is x squared plus 9x plus 15x plus 9 times 15. $135. Right, this is 27. And 9x and 15x will give us 24x. And then you're going to subtract your 27 to get a 0 because you have a quadratic equation. So we have 135 minus 27. 108. And so you have to work on your factoring there, like signs both plus. And I had to just go through my calculator. This was not something that, 108 is not something that you know necessarily. So 1 times 108, and then I divided by 2, which was 54. I tried 3, so 108 divided by 3, and that's 36. I'm getting closer. But that's your strategy. I mean, it seems silly, but that's what you're having to do. 4 times 27 is next. It does not work. We're still getting closer. 5 doesn't go. 6 times 18 gives 108, and it works. All right, so 6 and 18. So this will be x equals negative 6, and this will be x equals negative 18. So we're a little worried with 2 negatives there. We go back to the beginning and check each one. So we check the negative 6. It's good in the first parentheses because you have a positive 15 to go with it, so it's okay. Negative 6 plus 9 is okay because that's a positive 3. So this one checks. The negative 18 is not going to check though. Negative 18 plus 15, that's a negative. You're done with the checking. This one does not work. It is not in your domain. So your answer is negative 6. $21 looks like it would be the other kind with the log on both sides. The problem is this other number that's over there with it. It can only be one log on each side. It can't have anything else there. So this one is actually not the next kind. It is going to be the same kind we have had because we're going to move one of the logs. So because of the 4, I can't do the last method. So I need to get the logs on the same side. So I'm going to subtract this log base 2 of x plus 10 and get it on the other side. And that leaves me 4. Now these need to condense. And remember, if it's a subtraction, it's the log of a quotient. So we have log base 2 of x minus 1 over x plus 10 equals 4. Now we can change the form. So 2 to the 4th equals this. 2 to the 4th is 16. And different ways you can solve this. You can put this over 1 and do it like a proportion, or you can just multiply on both sides by x plus 10. All right, that would clear your fraction. So we end up with 16 times x plus 10 equals x minus 1. So we have 16x plus 160 equals x minus 1. At least we don't have to factor this time. So we'll subtract the x. So we have 15x plus 160 equals negative 1. And I need to move the 160. So, sorry, just give me a second here. So I'm going to subtract the 160. I had an error when I worked this before, but I didn't catch it. All right, so x is equal to negative 161 over 15. Now, to be able to check that, we just need to know kind of what is that equal to. All right, so we'll go in our calculator, and it's going to be negative, so 161 divided by 15. All right, so negative 10.7. All right, and so we'll go back and check. So I said negative 10.7. This gets thrown out in the very first parenthesis, so you don't have to look at anything else. Because it's negative. All right, I just didn't put the negative in when I did it. All right, it is negative, and so there is going to be no solution. There's nothing else to check. All right, it gets thrown out right here. So no solution or the empty set. All right, so here we would choose no solution. All right, we're going to go next to, let's see, what time is that? All right, so we'll go to 24. And this does have your logs on the same side, so you're going to condense. So these will go together. It is subtraction, so it will be the log of a quotient. And then you switch forms. So 8 squared equals this fraction, which is 64. And again, you can solve it as a proportion, putting this over 1, or multiply on both sides by x minus 5 to clear your fraction. So we have 64 times x minus 5 equals x minus 1. So 64x minus, I should clear that out, 64 times 5 320. All right, subtract an x from both sides, so I have 63x minus 320 equals -1. And you're going to add your 320. So if 63x equals 319 divided by 63. All right, so not such nice numbers. Now we have to be able to check that. So we are going to get an approximation for it. 319 divided by 63. And this one is positive. So it is like 5.06. And so we go back up to check, back to the original. Right, so your first parentheses would be okay. Your first log would be okay. So 5 minus 1 is 4. This one, this is why it was important to carry that out a little bit. 5.06 minus 5, it's okay. You're still getting something positive, even though it's very tiny. So this answer will work. It works in both. All right, and so what they will want is actually the fraction. As they didn't ask for an approximation. And if it would reduce, you should reduce. You can always check that in your calculator. It's not one I'm going to mess with for reducing. What happens on your graphing calculator, it will give you a decimal. And then when you try to put it back in a fraction, I'll just show you. All right. So I have the decimal. Now, if I tell this to, I go under Math menu and I say, put this back in a fraction, it would reduce it if it will reduce. Okay, it would not reduce. So that was your answer. That's how you find it on your calculator. All right. Question 25. We have a lot of logs in this one. And so this is going to be our next kind, which has a logarithm on both sides. You do need to condense so that you only have one log on both sides. So on this left-hand side, I'm going to put these together. And this is a sum of logs, so this will be the log of a product. And I am just going to put the 14 at the front. We're going to multiply it anyway. All right. And that was a 14. Sorry about that. All right, so we do have one log on both sides. What you can do here, and I was always taught a different way than it's presented in this part. I was taught raise both sides to the power of the base. Your base is E. If you raise both sides, don't write this down. If you raise both sides from the E, and this was E, once these are the same, the answer is just this part here that you were taking the log of. So, what you can actually do, whoops, and that was a natural log, is once you have it to this point where you have one log on each side, same base, you can actually drop the logs and set the arguments. These are called the arguments. You can set them equal to each other. Kind of like when we were getting the same base in the other part. So we can set the arguments equal to each other. So this will equal this, and we can drop the logs. So 14 times negative 11x plus 5 equals negative 3x minus 14. And we solve. This one looks like it will be a linear equation. So, that's the new step. Just get only one log on both sides, and then you can drop the logs. So you're really raising it to the base from from the base. And arguments will be equal. You do have to check at the end because there were logs in our original problem. So let's get a calculator to help us. 14 times negative 11 is a negative 154. And you can tell in these, some of these numbers are nasty. So you have 14 times 5 is 70 plus negative 3x minus 14. So I'm going to add a 3x to both sides. And this will be a negative 151x plus 70 equals negative 14. Subtract your 70 from both sides. So negative 151x equals negative 84. And divide by negative 151. So this will give us positive. And so 84 divided by 151. So I'm just getting a decimal there. So this gives us positive 84 over 151. I'm just getting a decimal to help me with the check. So 0.56. I have to go back. Right, and it's positive 0.56 in this one right here. It ruins the problem, right, because of that negative 11. So this is going to be no solution. I don't have to check in anything else. It is actually done. So it seems like so much work for no solution. Let's see what my time is like. Let me go to number 29. I had 26, but I'm going to skip it. You would put it together just like we did that one. This one looks scary because of those bases, but they're not even going to matter. But the two out in front, we did not see in a problem yet, so. All right, so first job is you have to condense this, and remember a number out in front was actually an exponent. So put that back on there. And now these you need to put together. I didn't write this back. So it is a difference, so it's going to be a quotient. Right, now you have one log on each side. You can drop the logs and set the arguments equal to each other. So you're going to set d squared over 7 equal to 175. So you can multiply on both sides by 7 to clear that fraction out. Gives us d squared equals 175 times 7, 1225. Now, remember when you solve for d squared, you're going to take the square root of both sides, but you get two answers. Right, and we'll just check this one. I believe it is a perfect square. And that's only because I already checked it. I would not know that. It is a perfect square. So D is equal to plus or minus 35. But we have to check. We have to check them both. So we go back to the top line. So the positive 35 is going to be fine. And these you can't plug anything in. You don't have a variable. The negative 35 is not okay because of the first piece. So negative 35 is extraneous. And that means it doesn't work. 35 is your answer. Good. All right. I want to go to a couple of application problems where you have to solve for something that's in an exponent position. So you're going to see these money questions again. The difference from these and the ones that you had in 5.1, 5.1 was just plug in, right? In these, you're going to have to solve for t, which is in an exponent position. And you will have to take a logarithm of both sides to make it come down. All right, so 33. So this is our formula for compound interest. And they tell us again what all these pieces stand for. All right, so we are going to invest $42,500. This is our P. The account earns 6% interest. We're going to change that to a decimal. Drop your percent 2 places to the left. Compound semi-annually. That means 2 times in a year. So our N is 2. And at the end we'll round. The piece we don't know yet is the account balance or the accumulated amount. And it says it will double after how many years? So we're looking for T. So this part is important to us. It will double after so many years. So I'm going to write our formula. And the P, they told us, 42,500. 1 is a constant. R is your rate. You switch it to a decimal. So 0.06. Compounding intervals, N is 2, and that is in 2 places. T is what you don't know. And this A you know because they said this is going to double, right? And we'll go ahead and just double the number. So times 2, and it gives us 85,000. All right, so we're good. We want to solve for T. Now, you have to have this piece that has the exponent all by itself before you can take a logarithm. So your first job is to get rid of this 42,500. It's multiplied, so you're going to divide. And you can push that in your handy dandy calculator. And it gives us 2. So if I had been really on the ball, I would have known, okay, it's going to give me 2, and that takes care of that. But I didn't think you would realize that yet. All right. So I wanted you to see to divide this out. All right. And so this leaves us 1 plus 0.06 over 2 to the 2t. The other thing I would do here, before I took a logarithm, I would put these numbers together. And I would do the fraction first and then add the 1. You want to make sure that it's always doing the order of operations correctly. Divided by 2, enter, plus 1. All right, so this is 1.03. So the 2t equals 2. Now I can take a logarithm of both sides. So I'm going to take a natural log of both sides. And I'm doing that to make the exponent come down. So this will come down. So I have 2t times the natural log of 1.03 equals natural log of 2. Now we want to isolate the t. Well, this ln of 1.03 is just some number. It's multiplied, so you're going to divide. The 2 is also multiplied, so you're going to divide. So you can divide both of those in one shot. 2 ln of 1.03 and that will isolate our t. Right? So this is going into our calculator. So natural log of 2. So ln of 2, you have to close that parentheses. All right. And now I'm going to divide by, I need to put this whole denominator in a parentheses because I have math there. Otherwise, it would just divide by this 2. So parentheses are your friend. 2 times natural log of 1.03, close and close. This is for the beginning of the denominator, all right, for this one. Okay, and we should be good. We'll click enter. So, and I think these should go to 2 decimal places. So 11.724, a 4 would drop off, so 11.72 years is how long it would take this to double. There we go. Okay. For the other, I'm going to skip the other piece of it because the only thing it's changing is the rate. So you would go in as 0.12. Here where we had the 0.06, everything else is going to be the same. And this one, it ends up being 5.95. So the rate makes that big difference there. All right, I wanted to save time to do one for you that looks different, right? Because these are really the same kind of problem. Right. This is a population problem. And I love that Dr. Kilman, when he wrote these, he picked local areas. So you might get Port St. Lucie, you might get Sebastian, Vero Beach. So he picked local ones and actually found the models for these. So our population model, which they give us, is 5900 e to the 0.01735 t. All right, and this says this models the can be modeled by this function. T is the number of years since 2020. Use the above function to answer the following questions. All right, what was the population of Okeechobee in 2020? So, P. So this model is for years after 2020. So if we want to know in 2020, then T would be 0 because the way they've defined it. And that is how it is in most of these model questions. with population. And so if t is 0, anything times 0 is 0. E to the 0 is 1, which means this number right here is your original one in the model, right? So for the first answer, so in t equals 0, it is 5,900. All right. So now our other question asks us in what year, so we're still going to have to solve for t. What year will the population be projected to reach 7,788? So that will be our projection, which is P 7788 5900 E to 0.0135 T. All right, so before we can solve by taking the logarithm of both sides, we need this piece with the exponent all by itself. So we need to get rid of the 5,900. It's multiplied, so we're going to divide. All right, so this we're going to put in our calculator and get a decimal. So 1.32, that's a lot easier to work with. All right, and now we are ready to solve for our t. And so we need to take a natural log of both sides to get the t to come down. So I'm going to take a natural log here and a natural log over here of 1.32 equals natural log of e to the 0.01735 t. All right, that will make this piece come down. Right, and remember the ln of e is 1, so you don't need that piece. Right? You can throw it out. So all you have is this equals this log. Well, you want t, it's multiplied by this, so you're going to divide on both sides by 0.01735. 0.01735. This will equal t. So we'll pull our calculator. So we're going to take the natural log of 1.32. Make sure that you close, because that's some number, divided by 0.01735. Enter. So this is 16. We'll round it to 16 years. Now, to answer the question is, in what year will it reach this? So you have to add the 16 back to the 2020 where the model started. So 2020, add back the 16. So in the year 2036, the population, according to this model, if it keeps moving at the same rate, would be 7,788. All right, we'll stop there. This is the section that will take you a little time to do. So allow some extra time when you're working on it. All right, you guys have a great day, and happy Easter.
Thank you, Professor. Happy Easter.
Thank you. Thanks for coming.